All right, good morning. We are ready to start days 3 through 5 in chapter 5. And this is going to be covering the characteristics of rational functions. So we'll be looking at our graphs. And yeah. So first up, we're going to just look at a linear function and a quadratic. And then we're going to move to dividing those two. So here, you should be able to fill this out without my help, because it says, let's investigate f of x equals x plus 1. What facts can you write about f of x? Okay, we know that's a linear function. You should be able to fill that out. So what I'm going to have you do is pause it and fill that out, and then check in to see that you get the same thing. Okay, so hopefully this is what you have. We know domain and range for all linear functions are going to be negative infinity to positive infinity, unless it's a horizontal line. And then your range will not be negative infinity to positive. But otherwise, those will always be the same. For the roots, you can either set it equal to 0, look at your graph, you can see it crosses at -1, and then end behavior you can also get from your graph. So hopefully you were able to fill that out. Next one is a quadratic. So again, nothing new. You should be able to fill those 4 boxes out as well. So go ahead and pause it and check back in. Okay, so hopefully this is everything you have. Quadratic domain is always all real numbers. The range is always going to change based on the vertex, whether it's a minimum or a maximum as well. So that's your y value of your vertex. The roots, we've been doing that for a while now. Solve that by factoring. You could have graphed it too and looked at it. And then end behavior, since it's quadratic with a positive leading coefficient, we know both ends need to be approaching infinity. So what we're going to do now is we're going to take these two functions, f of x and g of x, and we're going to divide them. So this is what's going to turn these into rational functions. Remember, we talked about on day 1, rational functions are a polynomial divided by a polynomial, okay? So let's go ahead and look at page 5, which is right here. So it says, consider the rational function. We're going to look at it with linear divided by the quadratic, as well as quadratic divided by the linear. And we're going to do our sketch from our calculator, and then we're going to determine the domain and range using our calculator, okay? So just a heads up here, as you look at rational functions for the first time, you're going to see that you're going to have asymptotes. And remember, asymptotes are lines that technically are not there, but that's what your graph, as your graph gets closer to those lines, your function will approach positive or negative infinity. So at this point, I want you to graph both of those. As you plug them into your calculator, please make sure you are putting parentheses when you plug those in, okay? So when you go to plug them in into your y1, make sure you're doing that before you hit divide. Okay, so this is what your graphs looked like. Now, I have drawn in asymptotes vertically and horizontally on the first one. And for p of x, just a vertical one. Again, when you look at these on your calculator, they do not necessarily draw in those dotted lines. Some calculators will, and what they're trying, and the reason that it shows up is because they're trying to connect, like if I look at f of x, they're trying to connect this infinity with that negative infinity, so that's why that line actually does show up. But the line is not there. It's just, it's what the graph is approaching as it gets closer to, in r of x, x equals 2. From the right, you can see that it's going, the graph is going to go up to infinity. As it approaches 2 from the left, it's going down to negative infinity. Now, something to note about vertical asymptotes, your graph will never cross it. Okay, so graph will never cross a vertical asymptote, but it can cross a horizontal. And you actually see that happening right here. So there is a horizontal asymptote that, notice along here over here in yellow, that as x gets bigger, your function's approaching 0 but will never cross from up above, and then all the way to the other side that I'm going to circle in yellow, as the function gets closer to the x-axis, it won't cross it. So as x gets really small, it'll just get closer to 0 but will never cross. So even if you did like trace and followed your values on your calculator, it would never equal 0. And maybe at some point your calculator would say it's like 11 point something times 10 to the negative 15th, which is essentially 0, but it technically never reaches it. So if we look at r of x and talk about the domain, you have 2 breaks in your domain, and those are your vertical asymptotes, because like I said, it can't cross, okay? So you have values from negative infinity until you reach negative 5, and then you have values from negative 5 to positive 2, and then you have values from 2 to infinity. But if you hit the trace button at negative 5 or positive 2, it's going to tell you there's an error because there is no output there. And then for our p of x, you can see the only break in the domain is at x equals negative 1. That's where we have that vertical asymptote right here. So it'll just be negative infinity to negative 1, union negative 1 to positive infinity. Okay, so go ahead and flip this to page 6, and it'll be helpful for you to write the function r of x and p of x on top so you know what you are referencing, because it's not written here on the new page. Okay, so first up, what it's asking us to do is to determine the roots or zeros. So by looking at the graph, it's asking for where does it cross the x-axis. So if you go back and look at your graph for r of x, you'll see that it's crossing at negative 1. And if you see at p of x, it's crossing at 2 and negative 5. Now, if you flip back to the first page, how do those values relate to f of x and g of x? So let's go over here. Notice that the root of f of x is negative 1, and the root of g of x is negative 5 and 2. So let's go back and take a look at that so we can kind of see how those relate to these rational functions now. So like we noticed here, negative 1 was our 0 for f of x. And 2 and negative 5 were the roots of g of x. So if you look at your function, see if you notice anything yet about that. Notice that in r of x, f of x is our numerator. Notice in p of x, g of x is our numerator. And those are your roots. So do you think it's safe to say the roots of a rational function come from your numerator? Answer is going to be yes. Okay? Now determine where r of x and p of x intersect the y-axis. We know how to get y-intercepts. We plug in, I don't want yellow. We plug in 0 for x. So if we do that here, we get 1 over negative 10. So our y-intercept is 0, comma, negative 1/10. And if we put that in here, we get negative 10 over 1. So its y-intercept is 0, negative 10. Okay? Again, that's something we've been doing for a while, so it shouldn't be too tough. Now, determine the value that r of x and p of x approaches as x approaches negative infinity, positive infinity to describe its end behavior. So you definitely want to go back and look at your graph. And as you look at your graph, you can even do the trace menu. As you trace all the way to the left, what are your y values getting closer and closer to? As you trace all the way to the right, what are your y values getting closer and closer to? For r of x, they both are approaching 0. And for p of x, as x gets really small, p of x gets really small. As x gets really large, p of x gets really large. Okay, so that's just looking at your graph and seeing where it's going. Next up is describe what occurs at the x values when the denominator of each is equal to 0. Will this happen every time? So if you look at your denominator of r of x, it's x squared. Oh. It's x squared plus 3x minus 10. And if you look at p of x, your denominator is x plus 1. So it says what happens when you set each of those equal to 0. Remember what happened here. We got...
Are you talking to yourself?
No, I'm not talking to myself.
Who are you talking to?
To my students. You say good morning. Say good morning. No? Okay, she's being shy. So notice what's happening here. If you go look at your graph, that's where you have the vertical asymptotes. And the reason you have vertical asymptotes there is because we can't divide by 0. Same thing for p of x. If you solve this, you have a vertical asymptote at -1. So will this happen every time? Yes, and reason is can't divide by 0. So if our denominator is ever 0, there will be a vertical asymptote because it will not be defined there. Okay, last part of today is just talking about where's the graph greater than 0, less than 0. So if you look at f of x, you have sections where it's above and below, okay? So for where it's greater than, or r of x, sorry, it's greater than 0 from -5 until it reaches -1, and then it's greater than 0 from 2 to infinity. And it asks, where do the graphs change signs? They're going to change signs at asymptotes and zeros. Okay, so that's the important part to look for. Okay, if you look at p of x, it's greater than 0 from, looks like -5 to -1. And then from 2 to infinity. It's actually the same. And then let's look less than 0. -infinity until -5. And then -1 to 2. And then for p of x, -infinity to -5. And then again, -1 to 2. Okay, because you got to think about it. If you're doing positive divided by a positive, it's positive whether it's one positive numbers in the numerator or the denominator. So that's why those have the same. And then determine when is each function increasing, decreasing. Are there any local max or mins? Why do you need to know? We need to know local max and mins for range, because sometimes you may have a break vertically. In these ones, we do not, okay? F of x is decreasing everywhere, but we cannot include the asymptotes. And then p of x is increasing everywhere. Again, you cannot include asymptotes here. So -infinity to -1. And then 1 to infinity. R of x is never increasing. P of x is never decreasing. So we're going to stop here today with notes, and this is for 3 days, this lesson. So my suggestion is to go and do page 1 of the homework. So you will find the first page of the homework for the assignment 3 through 5 on page 7 of your homework packet.